Cost, cost and savings analysis Daytona. Daytona changes. The bottleneck of Daytona is a Monza machine because it was not standardized, and the time that was calculated was 87 seconds for 2 Daytona machines. The other thing that was noticed is this swing shift had 3 to 4 people instead of the 5 to 6 people per shift, and then the backlog was about 10,000 parts. We calculated that working 3 out of 4 Saturdays a month OT to catch up on a backlog was 4 people, $29 per person per hour per day, and then 8 hours working, which was put us for $928 times 3 would put 3 Saturdays would put $27.84 per month. The end of the semester, there was 6 people on a team, so there was less manual time, and then people were closer to each other, so the time on Monza was changed drastically.
Daytona backlog. Lost sales revenue. It was 6 canceled orders, around 15,000 beats totaling. So totaling was $1,800,000. Additional labor costs in overtime was around 88,000. Additional leadership costs to support closing delivery gaps was 38,000. Additional support group cost was 29,000. Lost customer goodwill. November returns and reworks was 159,000, and returns and reworks was 23,000.
We have here our value stream map that shows the entire process of the product going through Daytona. Starts off with raw materials. One suggestion we had to eliminate bottlenecks was to potentially pre-inspect the parts. That way they can't come in already defected. Next, this is one thing that the company has already done. When we first started, the machine was right here, and they moved it to this position here, and that helped eliminate some of the bottlenecks with the 2 machines here. One suggestion we have is to put a table right here next to the Monza machine. And that'll allow the parts to be a little bit closer, so you're not having to walk and stretch from where they're stored right here on top of the lasers. We had another suggestion for this Monza machine. You can see it broken down here, including the table where the parts will be stored. They'll then be easily grasped right here and fed in. We wanted to have an example of what standardizing flow would look like. And so one idea we had is that you would stack them in the Monza machine. You'd have 5 parts at a time put in there, and then they would be sent through one at a time, and they'd be sent in exactly at the amount of time that you need in order to meet takt time. For example, if you had to do it, if you needed, according to demand, make a part every 10 seconds, and then you also anticipated a 10% rework, you would do it every 11 seconds. You would send, or every 9 seconds, you would send a part through the Monza, and you would have a timer with you even. So that was one example of completely standardizing the work.
We supposed that the bottleneck was the Monza, and so we wanted to conduct an experiment that we worked up with Alman. However, we weren't able to do that on the Monza exactly because the machine was tied up in process. However, Alman did find the precursor machine functioning to the Monza, which we did do an experiment on. This is the data that reflects the pieces that we put through the machine. We did 3 different sizes. All of them went through 1 at a time, 2 at a time, and 3 at a time. The interesting data that we can see here in red is that after rework, there was a high occurrence of larger differences from the top of the bit to the bottom, suggesting that perhaps the process isn't performing or having the desired results that are expected, which would be an interesting experiment to do on the Monza machine. However, what we can also glean from this, just as a reference in comparison to the Monza, would be that there is possibly little to no significant difference between sending one part through versus multiple parts. However, our sample size is very small, and it would behoove everyone to conduct the same experiment on a larger scale, or at least glean the data as recorded in process over a multiple day time period.
In trying to understand what changes could be made to the actual layout, tools, and processes within this within Daytona, we looked at a couple of areas that could be utilized in focusing the use of first in, first out of the parts, as we have already previously spoken about in regards to the Monza. The first thing I want to mention is the Devlig machine. In this, we suggest putting the raw materials cart, instead of it being a simple table with the parts stacked, we suggest using a inclined rack system utilizing gravity, so that the parts coming in will slide down directly to the operator, and upon completion they are placed on a rack facing away from the operator, so that the person operating the lasers and other machine further downstream will be able to quickly and easily grab the first in product one at a time. The next tool or idea that we thought of to improve the bottleneck that is the Monza machine was the diamond chute and dispenser hopper. These would be utilized immediately after the diamonds are removed from the etching lasers. You would place the diamond on its side on the diamond chute, which will then deposit etched diamonds into the hopper or dispenser to ensure FIFO in this process. After parts are loaded into the hopper or dispenser, by manually pulling the trigger, allow for 1 to 3 pieces at a time to be dropped into the Monza track to have the sides ground down. The use of these new applications would aid in the removal of the bottleneck that is the Monza